Okay, welcome back, guys, to part 2. Okay, so if you remember, we just finished looking at this 5-number summary. We'd also talked about how the range can be used as a metric to try to quantify the variation in a data set, but how it wasn't, depending on the data set, it could be very deceptive. Okay. And we looked at this 5-number summary that consisted of a minimum, a maximum, a first quartile, the median, which is basically the second quartile. It's like the 50th percentile. The third quartile or the upper quartile, how it kind of divides the data set up. And we had looked at these two box plots. And so we kept referring back to those same two data sets, those waiting times at Big Bank and Best Bank. Okay? And we kind of left off starting to talk about the standard deviation. So we really need a more robust way of measuring the variation of a data set, because the range just isn't going to cut it. Okay? And so you can think about, when we say standard deviation, think about the word deviation. What does that mean? Well, it means to differ from the normal. Or if we're talking about a data set, that means to differ from the mean, or the center of the data set, or the center of the distribution. Okay? And so we can start thinking about, okay, well, if I have a data set, I can find the mean, which is sort of like the center, okay? And then so all these other data values, how far do they differ from the mean? And the deviation is literally the data value minus the mean, okay? And some of these deviations will be positive, some will be negative. Values that are greater than the mean would result in a positive deviation, and greater values that are lower than the mean would result in a deviation that's negative. And so what happens then is you could say, oh, okay, well, maybe I just add up all those deviations. Well, the problem with that is that if you add up all those deviations, you'll always get 0. And the reason is because the mean is like the balancing point of the distribution, okay? So all those positive deviations are going to cancel all those negative deviations, okay? So just simply adding up the deviations isn't going to be sufficient. What we actually do is something like this, if you look at this formula. We take each of those deviations, we square them. The reason we square them is because if you square a negative number, you get a positive. So all of these squared deviations are going to be positive numbers. And then we add all of those up, and then we divide whatever that value is by the number of data values that we had, take away 1. And then at the very end, we take the square root of that resulting number, and that is how you find the standard deviation. Okay, so if I overwhelmed you a bit, you may recall me saying that finding the standard deviation by hand can be quite meticulous, and so you're going to want to use a calculator okay, for this. But if you were doing it by hand, I do want to illustrate this for you in this table. So what I've got here in this first column, these are the actual data values. Okay, so again, I'm referring back to that data set for the waiting times at, I believe it was Big Bank right here. Okay, so these are the data values. So if you were doing this by hand, what you would do is you would find all the individual deviations. So you would take each data value and subtract from it the mean. And if you recall, the mean in that data set was 7.2. So you get some negative deviations, you get some positive deviations, and then you square all of those. And when you square them, you get all these positive numbers. Okay, and then what you would do is you would add up all of this column right here, all of these squared deviations. Okay, you would add all those up, and then you'd get a number. And you would divide that number by n minus 1. N refers to the sample size. So here I think we've got like, I think this is 10 values, so it would be 10 minus 1. And then 10 minus 1 is 9. Okay, so when you divide, you would divide this total by 9, and that's what's called the variance, and your very last step would be to take the square root of that number, and that would give you the standard deviation. But as you can see, if you're doing it by hand, look at all these computations or calculations that you're going to have to do. Okay? You'd have to do every single one of these individually and record it. And then you'd have to square all these deviations, then add up all those deviations, then divide by 9 in this case, and then finally take the square root of that number. Okay, so fortunately for us guys, this calculator or app, whatever it is that you're using, will do all this for us, as long as we tell it what list to reference, or in other words, where to look for the data. So we're going to do this the same way. You're going to put your data in your list. And if you recall from part 1 lecture, I've got all my data in list 1. And what I'm going to do is go back to stat, just like always, go to calculate, go to one variable statistics, hit enter. Well, I need to change this back to list 1, so let me do that. Okay. Come down here to calculate, and we talked about the mean. It's 7.2. N is equal to 11, so that means there are actually 11 data values. And then if you recall, if you scroll down, you get the 5-number summary. We didn't talk about these other numbers. The only two we need to talk about are these two right here. This S of X and this sigma of X. Okay. S represents the standard deviation of a sample. Let me write this down in the notes for you. Standard deviation of a sample. And then sigma, that is the symbol. That's a Greek letter again. Okay, so similar to think about mu, if you recall, mu, the Greek letter mu represents the mean of the population, and then x bar represents the mean of the sample. Okay, so for the most part, you're not going to be using sigma here, standard deviation, because we're going to be working with sample data of a population. Okay. The only difference in these two numbers is that to find the sample standard deviation, you divide by n minus 1, and to find the population standard deviation, you just divide by n. That's the only difference. Okay. But anyway, look at these two numbers, 1.96. So if this is sample data, then the standard deviation is 1.96. I'm going to write this down. S is equal to 1.96, and the unit is the same. It's in minutes. So this means the average variance in wait time for this data at this bank is almost 2 minutes. Okay, and we'll talk more about what that really means, the average variance in wait time. Okay. Now, I also want to show you can find the standard deviation using Excel as well. Okay, and so what I've done is I input all my data right in here, and if you're using, I think this is Office 2016. Anyway, what you would do is just highlight. So you click and drag down to highlight all this. Or actually, no. You'll come down here to the column below all of this, and you'll come up here to the formula bar. You're going to hit equals, and then you can tell it to calculate the standard deviation with all of this data. Okay. But what you have to do is, if it doesn't appear right here in this drop-down menu, say mine does, it says standard deviation dot P, this means for a population, and then down here standard deviation dot S, that means for a sample. So I would click on this one. Now if that's not showing up for you when you click on this, then you need to come over here to formulas, and let's see, you need to come over here to more functions and go to statistical, okay, and then you can scroll down and it's standard deviation, but standard deviation dot S. Click on that, and it puts it in here, and this box will pop up. And so what you do is it basically wants you to give it the box that has the starting number, and then for number 2, the box that has the ending number. So I'm going to click, and it puts that in there, A1, and then I'm going to come down here. The second number is this. Well, no, I don't want to do that. Let me try this again. Now what you can do, I think, is just click and drag. No, that's not working yet. Let me try this again. You come over here and put in there equals. No. That's not. Oh. Let me go back to home. Why is it not letting me input equals there? Okay, hold on just a minute, guys, till I get this figured out. Okay, I'm back. I think it was just an error. What I had to do is save this and just reopen Excel. So I'll click down here in this new box. I'm going to hit enter, or equals, and you can see standard deviation.s is already here. It opens this box. Let's see. And I think you can just drag. Yeah, just like that. Yeah, that's what you need to do. And what Excel will do is start with the value in A1 and stop, go down this list and stop with the value in the cell A11. And so all I need to do is click OK, and it calculates it right here. See, we got the same thing, 1.96. You could also manually type this in up here if you want to. You just do standard deviation.s, you open parentheses, and it's telling you right here your first number, so you type that cell in, which is A1, and then you put colon, and then your last number you type in, which is in this cell, A11, close those parentheses, and you can see it highlights this whole column. And then when you hit enter, it'll calculate that. What you could also do is well, I won't go into that, but yeah, anyway, so that's how you use Excel. Okay, so I just wanted to show you that, to find the standard deviation. You could actually use Excel to find the mean, the median, all that stuff. Excel's a really cool program. But I'm going to continue to use this calculator because that's what I recommended that you guys get, or that free app on your cell phone. Okay, so you can see we got 1.96. Okay, all right. Well, we're going to continue. There will be, let's see, there will be some problems in your homework where you have to calculate the standard deviation. Actually, before we move on, let's also calculate the standard deviation for the data from Best Bank. Remember, this had less variance, right? This data was much closer to the mean. You can see that here in the histogram. So I'm going to come back to my calculator. And recall, if I go to edit, I had put that data in list 3. Okay, so when I go to stat and I go to calculate and hit enter, I need to make sure that I change this to list 3 because that's where I've got that data. And then I go down to calculate. And of course, you know, the mean was the same, the median was the same. But look, this S of x, or the standard deviation in other words, is 0.44 roughly. And so I'm going to put this in the notes. So I want you to see that difference there. So the standard deviation, this one is Best Bank. And this one is from the standard deviation, the wait times at Big Bank. This is only 0.44 minutes. Okay, so in other words, close, not even a half an hour. Okay, so the average variance in wait times at Best Bank is, I said half an hour, I meant half a minute, not even half a minute. Okay, as opposed to almost 2 minutes for the average variance in wait times at Big Bank. So you see the difference here. The difference in variation that we noticed earlier in the previous video is evidenced by the standard deviation, this metric. Okay? So remember, the standard deviation is a way for us to put a number or to quantify the variation that a data set has. All right, so let's continue. We're going to be talking more about the standard deviation. Okay. All right, so you know how to calculate it now, either doing it by hand or using your calculator or even using Excel. You will have some homework problems. All right, well, there's this rule of thumb. There's a way to get an estimate, an easy way to get an estimate for the standard deviation, okay, without actually having to calculate it. And this might be handy or of use if you were always trying to find the standard deviation by hand. As you can imagine, that would be very burdensome. And so this is the rule. It says the standard deviation is will approximately be equal to whatever the range of the data set is divided by 4. Okay? And so this is just an estimate, remember. And furthermore, you can get an estimate for the low value and the high value, or in other words, the minimum and the maximum, by taking whatever the mean of the data set is and subtracting 2 times the standard deviation. That'll give you an estimate for the low value. And taking the mean and adding 2 times the standard deviation will give you an estimate for the high or the maximum value in a data set. Now this is making some assumptions. This works really well for data sets or distributions that are symmetric. Okay, where the mean is pretty much right in the middle, and remember, this just comes from a histogram. So think about, you know, if a histogram was making this bell shape right here, or had this bell shape, then you could approximate it with this curve. So anyway, let's see. Yeah, so look, it says apply the range rule of thumb for each data set in the previous example to estimate the standard deviation of each data set. And how well does the rule work in each case? Okay, so let's do this with those 2 data sets. So Big Bank, the minimum value, I remember this, 4.1, and the maximum value was 11 minutes. Okay. And so if I'm using the range rule of thumb, the standard deviation is going to be approximately equal to the range. We calculated this above, but let's just do it again. The range would be the maximum minus the minimum, which is 6.9. Okay. So it's the range divided by 4. Well, the range is 6.9 minutes. well, I'm just clobbering the word minutes there. Okay, divided by 4. Let's plug this into our calculator and see what we come up with. And then we'll do the same thing. We'll get an estimate for the standard deviation for Best Bank. Oops. Alright, so 6.9 divided by 4, and we get 1.725. And this would be in minutes. Okay, so this is an estimate of the standard deviation, and if you recall from above, the actual standard deviation was 1.96. So this is not too far away. This is relatively close. Okay, now let's do the same thing with the data from Best Bank. Now I'm going to have to look back at our data set to see what the min and max were. Come back up here. The minimum was 6.6 minutes and the maximum was 7.8. Okay, so the minimum 6.6 minutes. The maximum was 7.8 minutes. And so again, the standard deviation is going to be roughly equal to the range divided by 4, where the range would be 7.8 minus 6.6, which is 1.2. So in other words, 1.2 divided by 4. And guys, this is actually going to be 0.3 minutes. Now compare this to the actual value that we obtained, which was 0.44 minutes. So you can see that this range rule of thumb, or this estimate for the standard deviation, is not too bad. Okay, it's not off all that much. But again, like I said, this really depends on your data set being fairly evenly distributed or fairly symmetric. Okay, if you look, let's see. Well, yeah, I mean, this data set is, it's actually fairly close to being symmetric. You know, if you were to kind of do something like that, it's not too far. And this one is sort of fairly symmetric. It is actually skewed to the right a little bit, but there's so much variance, or excuse me, so little variance in the data to begin with, it didn't make a whole lot of difference. But the more evenly distributed your data set is, then the more closely these estimates are going to be to the actual standard deviation of the data set. Okay. All right. We've got a couple more examples here. Well, we did example 4. Okay, it says use the range rule of thumb to estimate the standard deviations for the waiting times at Big Bank and Best Bank. We did that above. I'll just go ahead and recopy it real quick. So Big Bank, we came up with 1.725 minutes. And I'll just say from above. And then for Best Bank, we call it Best Bank for a reason, because the consistency in those wait times is about this, is very consistent. Okay, and we came up with 0.3 minutes. Those wait times. All right, so let's try to tackle this last one. So example 5 says studies of the gas mileage of a Prius. Okay, so a Prius is just a hybrid vehicle that Toyota makes. Under varying driving conditions show that it gets a mean of 45 miles per gallon. Okay, so this is the average. With a standard deviation of 4 miles per gallon. So they're giving us this information right here. And the question is to estimate the minimum and the maximum gas mileage that you can expect under these ordinary driving conditions. Well, this refers back to the second part of the range rule of thumb, where you can get an estimate of what the low and high value of a data set are if you know the mean and the standard deviation. Okay, so we're going to be using these two formulas. So the minimum estimated gas mileage would be equal to the mean minus 2 times, I'm just going to abbreviate here, the standard deviation. Okay. So the mean, they tell us, is 45 miles per gallon mpg minus 2 times the standard deviation. They tell us that it's 4 miles per gallon or mpg. And if we do this math, we get 45, oops, I'm going to ignore the units for a minute. We're going to get 45 minus 8, and that would be 37 miles per gallon. Okay, so this is interesting because we don't actually have the data to look at. If we had the data to look at, we could just look and see what the minimum was. Okay, but we can use that range rule of thumb to give us an estimate that probably the lowest value in that data set that they used to find the mean and the standard deviation was 37, or around 37 miles per gallon. And then the maximum, the estimated maximum fuel economy would be the mean plus 2 times the standard deviation. Okay, so again, 45 miles per gallon plus 2 times 4 miles per gallon, and this will end up giving us 45 plus 8, which is 53 miles per gallon. Okay. So, in the context of this problem, you could say, okay, well, under ordinary driving conditions, you could expect a minimum of 37 miles per gallon and a maximum of 53. So, think about this. You're probably going to get a minimum when you're driving around in town, perhaps, where there's a lot of stop and go traffic and your fuel economy is at the least. And then you're probably going to experience your maximum fuel economy when you're out on the highway. Okay, let's say you're driving from Little Rock to Memphis, or you're going on a trip and you're not having to stop. You're just setting the cruise control at 70 and you're going. Okay. So anyway, these last two examples just utilize this range rule of thumb right here. Okay. All right, guys, well, that's it for this section. For your statistics project, remember, you will be calculating the standard deviation for your data set, and you have to talk about the standard deviation as well. Let's see, you'll also have to find the 5-number summary for your data set as well. Okay, so refer back to this video if you need to. All right, but anyway, I'm going to let you go for now. We've got one last section in Chapter 6, and that is 6C. So I'll see you there.